All right, folks, I think we're going to get going. I see the numbers are still going up, but we're about a minute after 2 o'clock. So again, we thank you for being here. What we wanted to talk to you about today is your last line of defense against ransomware. And we hope that you find the information today informative and compelling, as we have at Champion here when we partnered with BullWall from the UK and with specifically their ransom care solution kit. So here at Champion, we actually have over 50 security related partners, and you're going to see some of those come up on the screen here. We sell them because we believe in them, and they work. They're great solutions, and these tools are your first line of defense and in place to prevent bad things from happening. And what we see with a lot of our customers is they place multiple layers of these different security products in place. And I think over time, people learned that no single tool is effective 100% of the time. And that's why they do this layered security approach. The solution we're going to present here today is not a next gen version of one of these tools, nor it is a replacement probably for anything you have in your toolkit. It is laser focused on ransomware and containment of this issues. And we're going to assume that most people on this call have a decent first line of defense in place. But really what we're looking at is what happens if this line is breached at any point. So on this next slide here, I have a number 3, and it may not seem like a big number, but to me, it's 3 too many. And what that represents is the number of our clients in this past quarter that have called Champion after they had a ransomware infection. And of course, when we engage with them, our initial reaction is to find patient 0 to understand what happened. And it varied. Endpoints not being updated, EDR tools not completely installed everywhere, or they were suspended, or human error. The list goes on and on. But in each case, this was not the customer's concern at the time. It was their business was down anywhere from 30 to 70 something percent between those different customers of people not being able to do their business, and they were severely impacted. They were kind of at a standstill. And the end result is the reason why it happened simply wasn't important, simply that it did happen, and their lack of containment was really what happened here. So with that, I'd love to turn it over and let the guys introduce themselves from BullWall at the UK, and take it away, Andrew, Andy, and Morton.
Perfect, thank you, Dan. So just as an introduction to our side, so the team from BullWall on the call today. So my name is Andrew Grant, one of the account managers, and I work very closely with Champion. We've also got Andy Walsh on the call, who is our lead technical engineer, and he'll be going through the demonstration of the RC technology. We've also got my colleague, Morten Gammelgaard, who is VP of Sales and Operations globally, and we'll be able to take any questions towards the end of the call. As a bit of an introduction to BullWall as an organization, we've broken out of an organization called the EC3, which is the European Cybercrime Center, similar to the NSA in America and the NCCU in the UK. And within that, there was about 3 ex-cybercrime professionals that were looking at things like ransomware, data breaches, and insurance fraud on a daily basis. And with that, they looked at different ways that may be different to traditional defenses, on how to combat these threats to organizations. We're headquartered in Denmark, and we also have offices in the UK where we look after our UK and US operations as well. So as an introduction to the RC technology, what this solution is on a really high level is a 24/7 automated containment solution. And as Dan's mentioned, it's laser focused on that issue of ransomware encryption. So where you would have solutions to block the threats or ransomware attacks from happening, what we do is deal with that outbreak scenario where that cost and damage to the organization really happens to the business. What we've got on the slide here is a handful of organizations, and this could have been multiple organizations. There seems to be 2 or 3 rather high profile cases globally that seem to make headline news around ransomware attacks. On the screen, I've got examples like Travelex, which was back in January, but the key part with that case is it was 32 days of downtime, a massive ransomware demand of $6 million, and the knock-on effects it's had to a $1 billion organization. We've also got organizations recently such as Honda with 218,000 employees, massive knock-on effects to their production line and evidently their business as a whole. We've also seen during the COVID pandemic in Europe, the largest a healthcare provider, Frenescence, with 300,000 employees, take a hit during this tragic time and the knock-on effects it's had across their whole organization. But the key point of this slide, not just that they're large organizations and they've had these large high-profile attacks that have been devastating to their business. If you look to the left-hand side of the screen, that analogy of that wall of perimeter that Dan's spoken about, whether it's your antivirus, your firewall solutions, endpoint technology, or any layer of security you're looking to block the threats, that same analogy is happening on a daily basis of that ransomware encryption breaking through that wall of perimeter and starting that encryption process off. And it's that analogy of once that encryption process is kicked off, how can you actually stop that from spreading throughout your network and encrypting all of your data? Obviously, these were quite high-profile organizations, but we're also seeing it from a service provider too, who are massive organizations who cater for lots of individual businesses. And again, the same analogy is they would have already invested in these technologies to block the threats in the first place. So to put it on a higher level, what we're looking at with organizations from an attack surface perspective is levels of email scanning, corporate firewalls and email gateways to block all of these threats from coming into the organization from that external traffic that we're looking to protect against. But what we're seeing with the cyber criminals is that enhanced attack vectors that we need to consider. So it could be things like user awareness training, which is obviously really useful for your end users to be aware of what potentially not to click on if it looks suspicious. However, that's never going to be 100% to block any of these threats looking to start that encryption process. Another example is what we're seeing from more of an advanced level is where traditionally organizations might have been circumvented by things like an RDP session, where the cyber criminals managed to social engineer a password, and they've managed to do the reconnaissance within an organization through maybe understanding the financial information, so they know how much to demand from that business, and the employee information, so they know where that key crown jewels data is, and they know where to start that encryption. But the newer versions we're seeing is looking to go into the IT services that you're running, whether it's your endpoint, your firewall, your AV, or even your backup synchronization. And on that point of encryption, disabling those services from running. So in a sense, the solutions that you thought may have blocked that threat in the first place weren't even turned on at that point of encryption. We're also seeing the advancement of how they're managing to circumvent antivirus solutions and that endpoint technology. So obviously there's the variants of vulnerabilities and patches to keep applying across your OS and applications on all of your devices. But there's a lot of new techniques that are able to bypass these security solutions. And one of the examples on the screen being the replace bypass technique, managing to get through a lot of the traditional antivirus vendors, but also the newer next-gen technologies, if you like. And the key issue we're seeing, especially with this costly downtime it's happening to organizations, is this critical time gap they need to consider. And there's a few areas that's a threat to organizations to think about here. And what you're seeing on the right-hand side is a detection rate across all of the antivirus vendors, where you're seeing 0 out of 58 across a 2-day period you're looking to detect this. The issue with this is the cyber criminals are looking at this information as well as us. And as soon as they see one of the antivirus vendors move from that undetected to detected, they simply rewrite the code and they re-release that ransomware into the wild. Another issue that comes with an antivirus vendor is the agent that's deployed on each machine. And the process with that from an antivirus perspective is understanding the new executable, testing it, publishing it, pushing it to you as a customer, and then you need to test it, publish it, and push it out to every device on your estate. And again, that comes with a time gap where the cyber criminals are looking at to look to penetrate your organization. The other aspects are obviously areas that are growing over the last few years with things like BYOD, mobile devices, and even IoT security, and how you look to protect against these newer different aspects of IT within your estate. So that really does pose the question of, is 100% prevention going to work 100% of the time? And the difference between a ransomware attack, which happened on the average at the moment every 4 seconds to an organization, and how you block against that. But what we're seeing with the newer strains is they're looking to circumvent them very easily. So as soon as a threat looks to come through and the virus is actually initiated and potentially it's circumvented your firewall, and then it's circumvented your antivirus or your endpoint detection and response solution, regardless of the name of the vendor, as soon as it's circumvented once, it's then freely or whitelisted onto your network to start encrypting all of those files and those file shares and taking down your organization. And we're seeing that a lot with the Maze ransomware, which is a very prominent one, which is looking to take down a lot of businesses at the moment. And we're seeing that from a detection rate. If we go back to that critical time gap, 14 days after the first known release of that ransomware, a majority of the AV vendors hadn't even had this as a supported executable within their solution. So within the RC solution from BullWall, what we do very differently is we don't care about how the attack comes into your organization. We care about what happens to your data. So as soon as that virus breaks through your firewall, it's circumvented your protection on the device. As soon as we see that encryption within your files on your file share, we'll very quickly look to respond and isolate that user and device so that encryption process cannot spread across multiple machines and multiple file shares, and limiting that damage from a ransomware attack. I'm not going to go into every single name on the slide, but what we're showing here is about 200 different vendors from a security perspective, all across prevention. And it shows the amount of point products you can consider. And it's the good stat, around 4 to 7 different vendors are within organizations to block threats from causing that attack to happen. But the amount of different areas from a vendor perspective, but the amounts of different point areas there are to consider when actually blocking the threats as an IT department. And there could be certain scenarios. There could be technology to do sandboxing or incubation of those vulnerabilities within your environment. And as soon as the hacker understands that process, the newer variants of ransomware are just putting time delays on that vulnerability. And as soon as that vulnerability has been essentially whitelisted through that sandboxing process, it's then free to start encrypting your data and essentially bypass these technologies. We've also seen areas from an IoT security perspective where attacks have been initiated from things like security cameras. They've been purchased for a business purpose. They've been installed to actually run as they've been bought for that reason. But the software behind it's been pre-written with ransomware. But because you've whitelisted it and you can't put an AV agent on an IoT device, essentially, again, that same process of whitelisting it onto your network has happened again. So on a really high level, what those solutions are looking to achieve is that almost judgment decision, if a vulnerability is good or if it's bad, and they allow it onto the network, or if they block it. And within the BullWall technology and the RC solution, our last line of defense has 4 key steps we look to achieve. So the first point is around detection and how we look at your data. So once we're understanding what's happening to your data, whether it's illegitimate or legitimate encryption, we're able to fire off our responses very, very quickly. So as soon as we've detected enough illegitimate encryption within a file share, we'll very, very quickly look to respond accordingly to that. So whether that is from a response plan perspective, isolating a user's device, removing them from Active Directory, dropping a VPN connection, for example, or even on a cloud environment, we could disconnect their SMB share permissions. In conjunction with actually responding to the actual attack, we're alerting you as the IT department to give you more control back of what's happening to your data. So the first point of call, we'll send out email alerts, we can get SMS messages sent out, and you can also get sirens going off in your IT department to essentially pull all attention to the dashboard to show what's happening to your data. The third point is more around that damage limitation perspective. So with a ransomware attack, it's about 8 to 10,000 files within your environment that are going to be encrypted at a very, very rapid speed. And the cyber criminals aren't stupid. They'll normally kick this process off maybe on a Friday evening or a Saturday morning when no one's in the office. And as an IT department, you're first aware of this encryption maybe on a Monday morning. At that time, your whole data infrastructure is likely to be encrypted at that point. So what we do when we've responded and isolated that device, we'll limit that encryption process to a handful of files. And the key point is we do need to see some encryption happen. So this is the process of those other solutions have failed, and we've kicked in as a response plan. So we'll limit that encryption to 5, 10, 15, maybe 20 files within your environment, and we'll pinpoint that to one user that's been infected by ransomware. That gives you the smaller process of look at the recovery process of those files, which we provided CSV format. So linking to your kind of backup strategy, you can get that one user back up and running in a matter of moments. So instead of an organization being down for weeks on end, it's a matter of moments. You've actually stopped the ransomware and you've kicked off that recovery process. The fifth point is more from a compliance perspective, and especially from a European perspective. We've got GDPR that we need to abide by the rules for, and obviously different legislation across the states and the US. And they all kind of say a similar thing around personal information and reporting it if there was a potential data breach associated to it, and avoiding any of those fines. So within our reporting capabilities, after every incident, we generate this report automatically. And within that report, we provide a timestamp of when that attack started and when it stopped, and also that list of encrypted files that potentially have personal information and that you need to go and understand which files do and which files don't. But again, considering that's 5 to 10 files, then your whole data infrastructure looking to rebuild. This slide's more of a simulation of what could potentially happen, and showing you that domino effect of of files within your environment, whether it's your Word, PDF, Excel, JPEGs, all being encrypted at a rapid speed within your organization. So this is the scenario if a ransomware has broken past your endpoint protection, your firewalls, your AV, and that encryption process and outbreak scenario has happened, and it's now kicking off that encryption process. So the first point is, would you be able to understand which files are being encrypted and where they reside within the organization? So are they on premise? Are they in Azure? Are they in AWS, for example? Once you've understood which files are being encrypted, it's trying to understand and pinpoint where that attack's actually started and initiated from, or identifying patient zero. So for example, maybe the individual that's clicked on the email attachment to kick off that ransomware attack and encryption process. If you can't pinpoint who's actually triggered the attack off, how can you pinpoint, how do you actually stop that ongoing encryption? And the nature of ransomware is obviously to go through one file share, jump across to as many as you can, and in some cases even go after your shadow and backup copies, which makes question 4 very difficult to answer, but more linked to your backup procedure. How long would it take to get those files restored? The fifth point, again, around GDPR, but also any regulations that you may need to report this incident to. If there was any personal information accordingly to these encrypted files, how do you avoid any fines by accurately and quickly getting this information ready for those governing bodies? And just before we go into the demonstration, I just want to talk a little bit around the architecture of the technology. And there's 2 really key points to note. So the RC solution is an agentless technology. So we have no rollout on a desktop, a laptop, file servers, or storage platform. All we are is one VM within your data center. And that's enough to cater for thousands of users as a very scalable, lightweight solution. The other key area that we're looking to really help you with is no additional network overhead, where maybe some other security solutions may recursively scan your network and add network overhead in that sense. What we do is listen to the existing traffic that's already on your network. So that this is based off the Microsoft technology within a network, within a file share. If someone was to rename, create, modify, or delete a file, and that sends a network broadcast up, all we're looking at is the heuristic file change to that encryption to understand if that is legitimate or illegitimate. And again, if it's illegitimate, we can then kick off our response plans accordingly to that. The same methodology works for the technology around cloud connectors as well. So obviously this day and age, there's a lot of organizations using the capabilities of Office 365, SharePoint, Google Drive, or Dropbox. What we have is built-in connectors for all of these, and the response might be slightly different, but we still have the same method of stopping that encryption. If a user was on the corporate network or they were dialed in via a VPN, we would definitely be able to see that machine, and we could isolate that user's device, we could remove them from Active Directory and customize the scripts that way. However, if a user was working from a hotel lobby or a Costa or a Starbucks and they weren't dialed in via a VPN, we wouldn't necessarily be able to see that device, but we would still see that encryption when they start to see that synchronization to the cloud. And what we can do in that scenario is we wouldn't be able to shut that physical device down, but what we could do is remove them from Active Directory, and we could remove their SMB share permission so they no longer have access to those files. And just to highlight from an integration and a response perspective, what we see here is our mobile phone application where we get SMS messages. We can understand what's happening to our data on a live feed and have that mirroring on our mobile phone. You can also have WhatsApp notifications. You can get alarms going off in your IT department, and obviously emails can be sent to the relative individuals within the business. The final point is how we integrate and work with other technologies. And if there is solutions in place around network access controls like Splunk or Cisco ICE to actually quarantine the devices, or even SIEM solutions where you may want to feed that information up to do that further evaluation process after the attacks happened. We have a two-way RESTful API, so we can talk to those solutions and kind of use the investment you've made in that area as well. At this point in the presentation, I just want to hand over to Andy and we'll go into the demonstration.
Hey, thank you for that. While you switch screens there, this is Dan again. I'm just going to comment. I did mention we had 3 customers, and you hit on a couple points there. And not to divulge information, but at the end of the day, some of that was because their protection system wasn't on all endpoints. So one of the things that I loved about this tool set was that it is agentless. I don't have to worry about updating agents. I don't have to worry about deploying an agent and all that stuff. And there's that network, there's no other network load on this, and how quickly you'll see in the video here how it contains the problem, because in that particular client, once they realized that stuff happened, which was a lot, their first reaction, they logged into the cloud and shut their entire cloud system down. They had no idea where it came from, and they were too scared to turn things back on because they had no clue where it came from.
Thanks, Dan. Just confirm you can see my screen, okay?
We can.
Brilliant. Okay, so what you're looking at in front of you here is the ransomware dashboard, and we'll go into a little bit more detail on that in a second. What I want to take you through is, before I run the 3 ransomware simulators, is just a basic configuration within the tool. So as Andrew mentioned, we need to add the shares that we want to monitor, and these shares can reside up in the cloud or in your data center. And if we don't have the necessary permissions within the tool, we can identify that we don't have access rights to this server, so we need to go back to the file share owner and ask for the necessary permissions to be granted. So as well as additional file shares, we also support DFS. So if you are using that within your organization, it's the same principle. We just require read access to be able to monitor that data. So once we've added the shares, we need to look at the different types of ransomware that we pick up on. So the first one here is the known bad. So these are known bad extensions, artifacts, and file headers. So as part of the subscription, we have a team in the back end that are regularly looking for new strains of ransomware. As soon as we come across any, they're automatically pushed out to your console. What that means is, as soon as it hits here, you are then protected 100%. So when you look at the different types of agent-based solutions where you as an organization need to download that update, you need to test that environment, you then need to distribute that to your clients. During that period of time, there is that still risk of vulnerability. And again, the way the world is at the moment, this becomes heightened with a lot of people working from home. But because we are an agentless solution, as soon as it hits here, we are protected 100%. The next thing we need to do is look at the known good data that resides in your organization. And this is done by looking at the file extensions, but more importantly, the file headers are associated to these extensions. Why is this important? Because when you look at the new strains or the unknown strains of ransomware, what they would do is they will come and encrypt your data. By encrypting that data, what they would do then is introduce a new file header into your organization. With our detection sensors, we're able to pick that up very, very quickly and put some isolation steps in place. So we don't care if a ransomware is released 6 months today or in the future, because the nature of ransomware is that it wants to encrypt your data. Because our solution is purely focusing on the data, when you look at all these new strains of ransomware that are hitting these large organizations, we're able to pick those up without any configuration changes to our tool. And what's key in this solution here from the whitelisting perspective is that we know that these extensions and these file headers are good within your organization, but obviously we don't know your company's data. So for example, you may well have an application that spits out an XLS spreadsheet or a document file that is an unknown file header from our perspective. So what we have is a built-in AI capabilities to actually learn about your data and populate this whitelisting. So next thing I'll do is take us into the detection sensors. So what we have here is 2 types of sensors. The first one being a direct sensor, which is a real-time check-in. And the second one is a cumulative sensor. So this is more like a build-up of files. So if you were to be hit by ransomware, what would happen is that cyber criminal would be placing ransom nodes within your file infrastructure, so you know how to get your data back. With our detection sensors, we're able to pick that up very, very quickly and put some isolation steps in place. So the way we work is on a point system. So you can see at the bottom left here, we have a maximum alert level. So this is built up from one detection sensor or a combination of sensors. So as an example, if I saw one known bad extension, I'd raise that value to 50. If I see more of these created at that rapid pace, very, very quickly, we'd reach the value that's been defined in our maximum alert level and start to isolate and shut the machine down. So what you're seeing here is totally open and customizable. So if you were to make changes in here, so for example, we increase this number or decrease some of these values here, The nature of ransomware is obviously the speed in which it encrypts. It's the 8 to 10,000 files per minute. So if we were to increase this number, all that would happen is you would have a handful more files encrypted, which again is better than having a whole file infrastructure down. At the bottom here, we have something called early detection settings. And what this is certain ransomware will come in and attack the top level of your folder structure or the bottom level of your folder structure. What we're doing here, and you can very much class this as honeypots, is we're placing one at the top and one at the bottom and then populating these with some dummy data. So if you were to be hitting this method, all that would happen is this dummy data would be encrypted. Our detection sensors at this point would kick in and start to isolate the machine. But what it does mean is that core business data that's in between these two honeypot folders won't actually be touched. So I'm going to go back now onto the dashboard. What we're going to do is just simulate some traffic. So this is what you would see. On the left-hand side here, our live log. This is what you would see within your organization. Again, what's really key to point out here is that we don't recursively scan your network. These are all file-based notifications. So as soon as someone touches a file, be it modified, created, deleted, or renamed, it's at this point we take a very small peek into the file to look at the heuristics of the file to see if any illegitimate encryption is happening. And again, also the beauty of this solution is because this traffic already exists within your network, we don't introduce any overhead whatsoever. In the center here, we have an activity live, and this shows us at any given time the files that have been modified, created, deleted, renamed, and then we just have a couple of graphical interfaces on the dashboard. But what you're seeing here is just a good flow of data. At this stage, nothing bad is happening. So what I'm going to do here is I have a laptop which I'm connected to, and this laptop is connected back to a server on the share. So I'm going to go into the share and I'm going to rename one of these files to a known bad ransomware variant. So you can see very, very quickly, and this is utilizing the SMB and CIF protocol, that within this live log, we've identified that an alert has been generated. We know the type of breakdown that is based on our detection sensors, but more importantly, we're able to identify who that individual is that's generated that alert. So in this particular scenario, all that's happened is John Doe has created a .fun file, probably not knowing that a .fun is a ransomware variant, but we've given you as the IT organization's ability to actually identify that and go back and educate this individual to why he's creating files in this format. But because no further encryption has taken place, what will happen is our alert level actually starts to decrease. But if this individual was then start creating files at a rapid pace, very, very quickly we'd reach the value that's been defined in our detection sensors and start to isolate and shut those devices down. So I'm going to jump back onto that share and I'm going to run an actual ransomware simulator here. So what we have is a simulator tool that contains ransomware with different types of ransomware variants. And we would run this prior to doing an installation of the solution to see if existing security solutions you may have invested in will pick up these types of ransomware. So I'm going to run something here called a DMA lockup. And what this will do is go and encrypt the files, but it won't change the file name. But what it does do is introduce a new file header into your organization. So we can see encryption's taken place and my machine now is in the process of shutting down. If I draw my attention back to the dashboard, if I had the sound enabled, as well as all the different alerting mechanisms we do have, a World War II siren would be going off. So this dashboard could be set up in your SOC center or your service desk, and you might not always be visually looking at it, but if you heard that sound going off, it would automatically draw your attention to the dashboard. So what we can see here is we can identify that ransomware has bypassed your first line of defense. It's actually starting to encrypt files. If I go to the share in which I've just attacked, what I can tell you is that these files have actually been encrypted because of the date stamp. And if I go into one of these files, I can no longer view the contents of that because of that encryption process. So we didn't have a solution like this in place. What would happen is that ransomware would quite freely start to encrypt the rest of these files. Bearing in mind, I've only got a handful of files in this environment. As an organization, you may well have terabytes worth of data, and in a matter of an hour, that whole file infrastructure could be encrypted, and that ransomware could then be looking to jump to other file shares within your organization. So what we've given the IT teams is the ability to very, very quickly identify that ransomware has bypassed the first line of defense. Very quickly, we reached our maximum alert level based on our detection sensors. We can identify the type of breakdown that is, but more importantly, we're able to identify the individual that started that alert and actually then look to contain it. So when you look at the likes of Travelex and all these large organizations that are being hit on a daily basis, yes, that ransomware would still come into their organization, but what we would do is contain it very, very quickly to stop that costly spread. So how do we go about shutting these devices down? So what we have in the tool is an asset list, and this asset list is populated by using a login script, which gives us information about the user and the device they're logged in at that given time. So we can identify the machine name, we can identify the username, the IP address, but more importantly, the type of device they're logged into. So this is really, really key, because as from the scenario we've just seen, we know it's John Doe who's triggered that attack. But what you can see here, he's actually logged into 2 devices. So with our built-in asset actions, we're able to put some isolation steps in place to kind of shut or quarantine that device, that individual, the devices that individual could be logged into. And all we're doing is pushing out from the server batch files or PowerShell scripts. So there's no new scripting technology. And if there's certain aspects that you want to follow when it comes to a ransomware attack, we can quite easily build that into the solution. So the first thing we've done is we sent that pop-up message to that individual, which can be customized. We could disable all network connectivity. So that's removing the Wi-Fi, the Bluetooth, the LAN, and any VPN. In the scenario you've just seen, we actually sent a force shutdown. So we just need to ensure that the ransomware account has remote force shutdown capabilities on the devices, which is managed through group policy. And as there's being a force shutdown, if the user was in the middle of doing any work, they would have no ability to save it. It would literally drop them off that device. If you have invested in things like Cisco ISC or any other NAC-based solution, what we can do with our two-way RESTful API is use that technology to do the quarantining. We can disable the user in Active Directory. So if I now go back into my AD, I have to re-enable that account to allow that individual to connect back to the network. As well as disabling the user, if you do have devices that have accessed by multiple people, we can also disable the device within Active Directory to prevent anybody else from logging into that computer. So we can isolate the user, we can isolate the device. If you did have a remote location and the attack happened there, what we can do also is isolate that site as well, so keep that ransomware contained within that environment. So again, as well as all the different alerting mechanisms we do have, if you have invested in things like SCOM or any of event-based solutions, what we can do is send an event to these types of solutions to actually generate the alerts. As you saw in the presentations, we integrate quite easily into SIEM solutions. So here, I just have a downloaded free SIEM, and it gives us a little bit of information about the attack that's just happened. So we can detect, we can react, we can respond. What about the recovery process? So we know during the time of the attack, there were some good files generated, but more importantly, we're able to identify the bad files that have been created. So we're able to drill into the individual that's generated that files. So yes, this individual will lose a bit of downtime, but we're talking about 12 files here and not a whole file infrastructure. So we can highlight these and export that to a CSV. So based on your backup strategy, this individual could be up and running in a matter of minutes. But because we know the exact location of the files that have been encrypted, that's actually going to help in that restoration process. So also we need to consider, do these files contain personal information? And as we touched on in the presentation, we are governed by something called GDPR across in Europe. But again, there is other authorities within the US that you might need to report this attack to. So if this does contain personal information, it can become a full-blown data breach. If it doesn't, you might want to still report this within your organization or keep a record of this in case anybody comes asking at a later stage. So within the tool, we can click on either of these buttons and then we have a populated report. This report can be customized with a company logo, but it gives us information about the attack that's just happened. So here we can identify when it starts and when it stops. And again, we're talking about 6 milliseconds here, yet we had a handful of files encrypted. We then can put a summary about the incident, the location, the server, but more importantly, identify the individual and the files where encryption's taken place. So just something to bear in mind in this aspect, if you were to be hit by the type of ransomware that I've just demonstrated, that goes and encrypts the files but doesn't change the file name, it's up to you within your organization to go and check each file within your organization to see which ones have been encrypted. And again, which one of these contain personal information. At that time, it does become quite a costly exercise. So what I want to do now is just take you through a different couple of scenarios in which ransomware could get into an organization. So the first one here is an Office 365. And again, a lot of people are moving towards the cloud, but that still offers that risk when it comes to encryption or ransomware. So what we've got here is a cyber criminal has created an alias to a web page. The end user has clicked on that web page and they're going to go ahead and accept the cookies. By accepting the cookies, they're not aware that this ransomware is actually starting to deliver its payload to the local device. And with the built-in cloud synchronization process, these files are then being uploaded up into the cloud environment. With our solution, we're able to detect this very, very quickly. And the key to point out here is actually agentless. So as you can see from my dashboard, very quickly, we've identified that files have been uploaded into the cloud. Very quickly, we reached our 100% alert level. More importantly, we can identify the detection sensors, but again, here we can identify the actual individual that's generated that alert. Now, depending on the location, if this individual was connected in an office, what we're able to do is put our standard isolation scripts in place to shut the machine down or disable or use an Active Directory. But what happens if this individual is working away from the office or not connected in via a VPN or even accessing this from a mobile phone? We wouldn't be able to see that device, but what we would be able to do is put something in place to actually stop that synchronization of files up into the cloud. So next I want to take you through, and at this point I think hopefully we should be able to see my camera as well. So what we've got here is a lot of organizations will prevent the use of USB charging cable, USB storage cables, but that doesn't prevent the use of a USB charging cable. And as you can see here from my mobile phone, I have a charging cable that's happily charging the device. So the scenario could be here is end users purchase this from an untrusted source, or even if cyber criminals hanging outside your office location providing these cables to individuals. These individuals are then plugging these cables in and not aware that these actually come preloaded with ransomware. And as you can see from the device, we're now in the process of shutting down. If we draw attention back to the dashboard, we can identify very quickly we've reached our 100% maximum alert level. We know the type of breakdown it is, but more importantly, we've actually been able to identify the individual and put that isolation steps in place. So really these last three scenarios, what I'm trying to show you is that we don't care how ransomware gets into your organization. What we are there for is to stop that costly spread, but more importantly, stop that costly downtime. So at this point now, I'd like to hand back to Andrew to continue the presentation.
Perfect, thanks Andy. Can you see my presentation screen?
We can.
Perfect. So what Andy's just gone through there is that simulation from a ransom perspective and understanding that we can see that encryption and shut down the device. But the other aspect is what comes from a ransomware attack is the cost associated to it. And what we've built within our on our website, we've built a cost of downtime calculator tool. So we can go through a few examples, and after the call, we can definitely share the link with you to kind of build up that scenario base of if your organization was to be hit by ransomware, how much it could potentially cost the organization. The key statistic on this slide to see is the average amount of downtime has jumped massively in the last 6 to 12 months from Coveware's report. So previously it was at 7.3 days, and the amount of high profile attacks we're seeing where it's a lot longer than that, going back to the example of things like Travelex when they were breached at the beginning of the year, it's the average is now 15 days. So that's over 2 weeks for an organization without any productivity and the costs associated to that. What I'll also show is our YouTube channel and what happens when there's new variants of ransomware that are quite unique in a way, and what happens with the larger vendors like Microsoft making these big announcements to make organizations almost vigilant to these newer strains of ransomware and how to almost combat against them. There was a big announcement for the one on the screen for a ransomware strain called Netwalker or Mail2, which is quite prevalent at the moment to organizations. What we have on our YouTube channel is multiple videos. Any new strain we come up against, we do a short recording of that. And similar to what Andy's just shown in the demonstration, is that ransomware strain being fired off, and without any configuration in the tool, us very quickly containing that ransomware based on the process of encryption that it brings. But on the screen, I just want to keep an eye on that 7th of March 2020 of when that announcement was made by Microsoft. I'm just going to jump across here. Could you just double check that you can see this screen now, Dan?
I can still see your screen.
Yep, perfect. So what we've got here is our YouTube channel. Lots of different variants. So variants such as Sodonoscopy, the one that took down Travelex, the Maze one that we went through earlier, which is very prevalent at the moment across initially Italy and then across Europe, and we're seeing a lot within the US as well, and massive organizations being hit by that strain of ransomware. But if we go all the way down here to the Mail2 Netwalker video, we can see a short recording of the ransomware strain being kicked off. We can see the RC solution containing it and that device being shut down very, very quickly. But the key point of this piece is the date we posted this was the 14th of February. So about 3 weeks prior to the big announcement by Microsoft, this solution had the known bad extension that Andy's shown in the demo available for all the customers prior to the Microsoft announcement. So what we'll do is share this video link after today's call. You can have a look at any newer strains that you might be of interest.